Thank you. I'm trying to keep it short. First off, it was like decisions today. So I brought some crochet cakes, but I could also like play Lego Star Wars today, but I decided to come over. Well, I'm a core developer for Icinga for 7 years already. I'm also a senior developer at NetWays, 3.5 years right now in Nuremberg. I'm actually from Austria, so right now you can't hear my dialect, but normally you do. I also took over the administration at Monitoring Portal with some other guys because it's a great community portal. And if you want to reach out, like it's DNS Michi on all social media channels and everywhere else. I cannot really abandon that name, but it's me. You love me, you hate me. But right now it's about the API. When we talked about an API, there were several things. We wanted to make sure that everything is running smooth. So it was like, could we expose the JSON RPC cluster API, or should we do something else? And looking at the internet, it was all like REST API, SOAP API, whatever we wanted to use. And we said, well, let's just go for HTTP. Provide a RESTful URL scheme. We also need to manage the configuration, or the authentication and authorization. So on the Icinga 2 side of life, you need to configure an API user object. I'll show that later on, how that works. So it's not like connecting there and getting everything, but fine granular permissions and so on. Everything is secured with SSL, so it's X509 using client certificates, or you could also go for basic out, which is known from HTTP and so on. So curl is easy as pie to use. The API user object basically looks like this. That's an example taken from the standard installation of Icinga 2 right now. So you're defining just an object with the type API user. The name is root in that example. Password is Icinga, and permissions is everything, which is generally bad. You should think about it when defining or configuring special users. Like one could actually go for like query host objects or query service objects, with also the possibility of defining filters based on, for example, a regular expression matching Linux for a custom attribute named OS on the host and on the service level. And you can actually use everything you know from the Icinga 2 language, which is like functions, regex, match, comparison, inside array, and so on. So it can get pretty complex. So fine granular permissions are possible if you just say, well, I want everyone to query the host objects or the service objects. You just pass that and it's fine. The idea behind the Icinga API is to initially, we want to create, modify, and delete objects. It's not only about querying objects. We also want to retrieve the information, which is querying all kinds of stuff, all config objects, the status information, the config object types, and anything else. And of course, if you're familiar with the external command pipe from the old world, we also want to run actions like process a check result, reschedule a check, acknowledge a problem, schedule a downtime, and so on. So that's basically what the actions are for. We also have events, which means you can actually subscribe to specific event stream type to like receive all check results or receive all state changes or all notifications. I'm trying to show that later on as an example. And of course, we also came up with the idea to provide a RESTful API for managing configuration packages. Because right now, if you have a sort of a distributed monitoring environment, you need to put like SSH and pushing your configuration files somewhere. And we thought about, well, we could put that into the API and actually manage that. So for us, it's like a new standard config API. You are not managing the files on disk, so you're not using VI or Nano or whatever. You can actually just generate that with your tool with, for example, the Icinga director, which Tom is talking about later on when he's finished programming. Yeah, the thing is, it's not only about just pushing one configuration package, which means some files, your host objects, your service objects, but also provide some sort of staging mechanism, which means you're pushing a config package, the Icinga core validates it in a separate process and says, well, it went fine, I'm just doing the reload, or, well, you broke something, please get out, and I'm doing nothing. But you can actually retrieve the error later on, and your monitoring doesn't get broken just because you pushed the wrong package. It also supports zones. So if you're deciding to use the cluster config sync mechanism, we are providing underneath etc zones D. You can actually build that into the config package tree and also say, well, the satellite gets this configuration, the agent gets this configuration, and you just can use the zone cluster config sync. So, and yeah, it's basically the Icinga director is using it, but I've also seen from the community support channels that the other guys like managing some sort of Puppet and Ansible modules are trying that out and manage some sort of static configuration, for example, like apply rules or global templates and so on. A bit about the event streams. As said before, you can filter based on, or you can tell the type and actually filter on that. With a check result, state change, notification, acknowledgement, comment, downtime. That's basically everything you can filter on from the event streams. You can actually use that, for example, to create your own notification mechanism or provide your own check result backend for like SLA reporting and other stuff. As an example, it's the URL endpoint events. You're putting a queue, which makes that unique. And you can add the types parameter, which is an array. In this example, it's just check result. If you want to have more of them, you just say types check results, types state change, and so on. In terms of filtering, we have status, objects, actions in the events. So it's not only you just blowing everything into it. You could go for a simple filter, which, for example, could be used to acknowledge a certain problem within an action. You're just putting in for services or just querying in that regard service or using the full name, which is the host, the exclamation mark, and then the service name. Or you could also use the advanced filtering, which is basically the same language from the Icinga 2 DSL, which in this example just uses a comparison between the service name. But you could also go for match, regex, union, intersection functions even. So it's pretty much everything you ever wanted from an API, in my opinion. So, and this is just the boring theoretical thing. Let's go for a demo. So, I'm hoping that, can you read that? Hopefully. I don't want to go down to 800, 600 resolution. So the thing is, PAW is an OS 10 REST API client, which is pretty awesome to work with, also for developing and demoing stuff. And the general idea is I'm querying with the GET request the version 1 object hosts. I'm sending no body because it's a GET request. And when firing that, I can see, OK, I get a result set with 5 items, which means I have 5 hosts configured, and I actually get all the known attributes directly from inside the core. So it's not limited to, like, from IDO or live status or other old-fashioned backends, just a limited set, but it's the full feature set. And you can actually see, like, the last check result, which also exposes the command line. So you can actually see what Icinga 2 is actually executing. So in this example, it's using check ping and the parameters. You can use that for your own calculations, for, like, example, execution start and end, calculating execution time. You get the exit status, the output, the past performance data. Oops. As an array in this example. Yeah, and basically it's everything. Okay, and also there's a vast dictionary. But that's just an example. So if you want a specific host, you can just put host like a simple filter. In this example, Icinga 2 is just the host name I want to see. And oops. Yeah, I get this one. The full name is Icinga 2. It's using host alive, and that's it. So another example for, like, listing a service. This one lists the ping 6. So I'm firing that. I'm getting ping 6. Hopefully it's fine because it's pinging localhost. Just a simple example how you can query that. If we are going further, for instance, we do have the ping 6 service, which is visible over here, hopefully, yes. So right now it's OK. And I just want to simulate a passive check result and say, well, this one is broken. So I'm sending an exit state, plugin output, performance data in. I can also specify the check source to let the user know where this is coming from, and firing that. And it hopefully refreshes. Yeah, on the left side. OK, yes. So it's totally live. So basically, the API receives the check result, processes it, dumps it into the database. Icinga Web 2 shows it to me, and it's gone critical because I said so. Well, when it's gone critical, I also want to, like, reschedule the checks. So hopefully it gets OK again. In this example, it's just rescheduling everything, I think. Yep. Or filter true means everything. So maybe don't do that with, like, 100,000 services. But in this example, it works. And hopefully, yep. So the recheck went fine. It's green again. And I've rescheduled the check. The last one was 20 seconds ago. That perfectly fits. Okie dokie. One more thing about the actions. I want to add a comment. For the type service, filter is service name is ping 6. Sorry. So I just the add comment action needs an author and a comment. So plain text, it looks like this. It's all JSON. And just firing that. It says, OK, I have a new comment. And I should see a new comment somewhere. Oh, yeah, there it is. So there's no core restart involved or anything else. It's just running live, adding your command, doing the checks, and so on. Now for the interesting part, if you want to create an object, you need to send a put request to the object's host's URL endpoint, and you need to put the unique name for the host. In this example, I'm just using example2.demo, and I'm providing several available templates and attributes. I'm using the generic host, and for the attributes, I'm just setting address, check command, and a custom attribute named operating system, or OS. So, object was created, okay. Just, oops. Yep, directly created at runtime. Icinga wasn't restarted, and it should soon start to check. So, and hopefully it just goes red. Oh. No, it doesn't. Okay, but you can see the address is set to .1.1, and the idea is to modify the address at runtime. So if you made a mistake or want to test something, the idea is to actually modify the host attribute, in the address attribute. So you're sending a post request to the very same endpoint. And Icinga 2 tells me, okay, I've updated the attributes. And hopefully over there as well. Yep. So you can see the address is changed at runtime. It's reflected in all interfaces, which in this example is the IDO database. So it still works and nothing is broken. Now for the fun part. You can also delete objects you've created at runtime. So it's just, again, the same URL endpoint, sending a delete request. And one thing which is important, when you're creating an object, it also evaluates all apply rules, which are statically defined. So in this example, I have SSH and ping4, which are static configuration files on disk. And Icinga 2 won't let me delete that if I just, oops. Yeah, whatever. If I just omit the Cascade 1 option, just to say that my demo is not a fake, it will tell me, well, the object couldn't be deleted, which is there are hosts, there are services depending on that host. So ping6 or ping4 and SSH are preventing that. And if I would just want to delete, no, not that. If I want to delete the services, which were also created at runtime, I need to say Cascade is 1, which just means recursive delete. It's dangerous, so if you're putting that into production in your scripts, test it properly. So nothing is more evil than a destroyed production system, just with some API calls. And the object is gone. So, yep, there are no services and no hosts found. Oh.
If you create a new object, does it also add new files to the configuration? Does it just push it into the
we are actually providing our own configuration package in the background, which is totally Icinga 2 internally. You can see that on disk, but it's independent from the database. So you can actually use Icinga 2 just with the API, but you don't need the database backend. If you have like a satellite somewhere and you want to just retrieve information, or if you want to like debug because a check is not executed, you can just enable the API. It's basically using the same port and mechanism, sharing it with the cluster protocol. So if the API feature is enabled and configured, the API user is there, you can just query it and say, well, last check result, command, I want to see it. And you can actually debug things with that. If you're creating an object in the background, it's just, we have our own configuration writer, and it's just plain text files on disk.
Yeah, so it does, survive the reboot.
Yeah. Or even the restart, so you're on the safe side.
What if you delete a host you define on disk?
You cannot do that.
Okay.
So it's when you're using the API, you need to ensure that it's exclusive to that, and you shouldn't really put like host on the left side, the other host on the right side. And we thought about like managing that somehow, but it gets overly complicated, and after all, you're shooting your head with like, can I delete that, this, and boop, and you have some sort of inconsistent state. And we said, if you're using the API, create object with it, you can delete objects with it, but independent from the other configuration methods. Okie dokie. If I just repeat that one, and also create another one. I just want to show you that I can delete multiple objects. So I have this one example, hello, I have two. Okie dokie, I think that will. Yes, okay, sorry, I didn't show you that. It's also possible to pass the body to a delete request, and in this example, it's just filtering for the demo inside the host name and says, well, Cascade is true, please delete it, please go to hell. So it's gone, and it's basically just for the demo stuff with creating, modifying, and deleting objects. Another example for something which is actually using the API. Maybe you know that from my previous talks. I've began starting to hack a dashing dashboard using the REST API. I changed the design and style a bit on the weekend, preparing for my talk. So it should be a basis for your own dashboards, for your own implementation. So if you like it, fork it, send a pull request on GitHub. It's all open source. The idea is to like tell you the uptime, the current version, problems, and also things like currently I have 2 hosts which are down. I have some random services running which are changing state every time, which makes the demo more interesting. And right now, I don't have anything acknowledged and nothing in downtime. But I want to change that and say, well, I know there's a global outage. I just acknowledge everything because I can do it. I'm the admin of my own. So I want to acknowledge a problem. I'm using the actions endpoint. If you want to know all the details about the parameters passed to the requests, it's all in the documentation. So it's huge, but you should at least read it to fully understand what's going on and what's possible with the API. I want to acknowledge and type service. The filter is everything which is not OK. That's also possible. You can filter for runtime attributes. because it really doesn't make sense to acknowledge something which is okay. Provide an author, send a command, and also enable notifications in this regard. So I'm firing that, and I see real-time, okay, I have acknowledged services. One is gone already because it changed state again, and that's it. I think I should see that in Icinga Web 2 as well, but dashing is more beautiful for that. Okie dokie, and then I could also go the other way and say, all the acknowledgements, super nice. My colleague did a fine job acknowledging everything. I don't want that, and just revoke them. So sending that back, and they are unacknowledged. You get notifications again, and so on. It's not the typical productive example, but it's really nice to just show you how the acknowledgements work, and it's just real time. And you actually get a feedback, which is a bit different to the external command pipe. We're just dumping something and waiting, checking the logs, checking the web. Right now, you can actually get a feedback. You get an HTTP status code. You get the output, which is a bit longer. And you can, if you're programming a script using the API, you can work with that feedback, which is basically good design. So another thing I wanted to show you for using the API, I'm using the Vagrant boxes. So I also have Grafana here. I'm not going into Grafana details. It's just throwing in some load metrics from a check. And the idea is to generate a new load check. Or not to generate, to create a new load check for the Icinga 2 object. I called it load minus real time. Because I say, well, check interval is 1 second, retrain interval is 1 second, and load, yeah, well, running Vagrant on a MacBook generates load. So let's just create it. No, I want not text, I want JSON. Prettier to read. Yep. And hopefully the auto refresh. Object was created, but it doesn't check. Ah, there it is. Need some data points. Hello. Ah. So you can see the object was created. It starts to check. It provides performance data. The Graphite writer dumps that into Graphite. And Grafana pulls that from Graphite Web. Not a big deal, but it's just real time and nothing you need to worry about restarting something or adding something. You can actually use the Grafana dashboard queries to just use a wildcard filter and have it in your graphs if you add a new service or a new host, and it's pretty nice. Okie dokie, I can delete that, but that's basically it. Another thing I wanted to show you is the Icinga 2 Studio or the Icinga Studio. This is currently a read-only graphical application, which is built for, I think, the current Debian versions, Ubuntu and Fedora as package. It's using the Icinga library and just connecting to the REST API. And I have the possibility to list all hosts, click on the host, and also get the attributes. Right now, for us, it's more for debugging, but we're also thinking about expanding that maybe to some sort of read-write mode or whatever comes to mind. Or if you have anything, it's built with Weeks widgets. If you're a good coder, just send us a patch. We'll review it and merge it upstream. But it's nothing spectacular, but it's cool to have it. Oh, it's also available on Windows. So if you install Icinga 2 in Windows, you also get the Icinga 2 Studio, which is important in some companies maybe. Yep. Ignore, just, yeah, it's a Mac problem. Maybe it's just because I'm using the latest Git master also. Another cool thing I found recently was like Bitbar, which is some sort of OS X integration. It's using the Icinga 2 API as well. So I could just refresh that and get everything back. I found it on the internet and I was like overwhelmed, because when someone uses your product or your interface, it's always overwhelming. It's pretty nice. I know that someone is working on Amsterdam on integrating the Icinga 2 API or the Icinga Web 2 API. And I think there will be more like some sys-tray clients monitoring your, or just showcasing your monitoring core status. Yeah, but that's it for that. Okie dokie. What else do I have to show? Yep, that's another thing which I wrote a while ago. The idea is like you have Amazon AWS EC2 instances. Currently they are all stopped. And the idea is when they are started, just have a hook, a script, whatever, which triggers that and automatically creates Icinga 2 objects. In that regard, just creating when you are firing up a new EC2 instance, have a hook, create Icinga 2, a host object, have the monitoring automatically in place, shut it down, run the hook again, and the host will get deleted. So you're not in the need to just restart your core because of configuration changes, but you can do that at runtime. So where did I clone that? I cannot do that over here. You need to have your AWS private key so it actually works. So I'm doing that in my home directory. Icinga 2, floop. So it's querying the EC2 API, found some public DNS, and creates a new host. You can ignore that error because it's trying to trace if there is a host already existing in Icinga 2. It's just a demo script, so you can use it for your own implementations if you want to. If you don't like Ruby, just go for some other language. It's pretty easy to actually do that and to prove that they are actually here. Let's see about, no, not the dashboard, the overview, hosts. And I have some EC2 hosts. And just because I have some apply rules, I also get ping and SSH because it's a Linux box. I could fiddle with the security cubes in EC2 to allow ping. I think SSH is enabled by default, but I really don't like the interface, so I'm not doing that right now. And if I stop them again, yes, I want that. Just need to wait a little time until they are stopped. You can find that code on GitHub. I will show you the URL later on, and we are also putting the slides on SlideShare and so on, so you can find everything you need. Or if you don't need it, yeah, well, then don't use it. So they are stopped. Just try it. Okay, thinks they are gone. and they're gone as well. So the monitoring core is still up, so the uptime is like 2 hours, no restart involved. And yep, I think that was everything except for that. Oops. I did that for the last Icinga Camp, and it was really funny. The only problem is we need to enable course support for the API, so it's just using a wrapper. But that's some JavaScript library I found on the net, and I thought the older generation knows about it. Maybe we can put it into Icinga Web 2 as an add-on. I already have a feature request for that open, so just go there and send +1. Yep.
You're using Figar as well?
Figar?
Yeah, that's VI with clicky in it.
Oh, interesting. I need to look into that.
We just have 3 months of development now for that.
Yep, I think that's basically it. Let's just go back to some slides. Oops. So you've seen the Icinga Studio. As said, you can actually use that in your favorite distribution and also on Windows. Maybe we are porting it to OS 10 because Icinga 2 also runs on OS 10, but we don't have packages right now. I'm actually developing it directly on OS 10. You could also use the Icinga console. This is also described in the documentation. There's also an eval parameter to just evaluate config expressions. In that regard, it's using an object accessor method named getHost for the actual node name, fetching the last check result, the command, and you get the command line. This is pretty nifty if you like wanting to check my check command doesn't really work and why is the parameter not added. And it's all unknown in your web interface, and you can actually just fetch the command line executed by Icinga 2 and just work with it. I'm doing that all the time. You have dashing. So just putting that into shape, and if you have anything like suggestions or proposals, make it more beautiful, or just adding new widgets, just send them in. The director, I don't want to spoil anything. That's an old screenshot, so I'm also hoping for new stuff later on in Tom's talk. The bitbar thing, that's PAW, because many people asked after my last talk, what is it, why can I get it? Well, you can buy it from an online website. I think it's $50 or something like that, or 30, but it's totally worth it in my opinion. I think there are some add-ons for Chrome and Firefox doing the same thing inside your browser, or you can just go for curl or whatever. In terms of the community, I've collected some links and add-ons which I know of, which are using the Icinga 2 API. There's a Python library, work in progress, the bitbar thing. For the event streams, Blaring created a logstash input, which looks pretty awesome. There's also Flapjack events founded yesterday or last week, which just forwards the event streams into Flapjack, which is a notification event stream multi-processor ding-dong. I haven't tested it myself, but all the cool DevOps guys says it's cool. For the actions, a Lita handler is some sort of ChatOps thing. Sarkuli is end-to-end testing on Windows. They're also forwarding the check results or the results of their end-to-end tests directly to the Icinga 2 API, not using the command pipe. MQTT1 is a project by JP Mans, which is some sort of message thing. Also processing check results. OpsGenie is for correlating alerts and events and so on. It's best to just click on the links when the slides are online to get informed. I'm honest, I also don't know much about them. And there are some articles. I also found that Géant is actually using Icinga 2 somehow. Maybe. They're evaluating it. And I think they're pretty much more using the API. What's next? I think there should be more libraries for like Ruby, PHP. Python is already there. I don't know, Go, Rust, whatever. Maybe someone writes an official Foreman or Puppet Ansible chef hook for creating objects, managing objects, querying that, getting that together, because we are creating the API for just integrating all the cool stuff, the cool tools which are around. Maybe it's also worth like looking more into the event stream integration with Elastic and Logstash, or vice versa, somehow pushing alert triggers from Elastic or Logstash to Icinga 2. From the add-on side of life, Naxtamon, Nacris, because it's using currently live status or IDO, could use the REST API as well. And there are some other collected examples for the Icinga 2 API. Also, all the links which are in the slides. So if you find anything or just want to let us know about a cool new project you wrote using the Icinga 2 API, just send a pull request and we'll happily add that. So for the conclusion, I hope I'm in time. No? Yeah, okay, I'm not in time. It's just the last slide. Just download Icinga 2, play with the Vagrant boxes. So there's everything which I showed today are actually in the Vagrant boxes. You need the last Git commit from yesterday, I think. Read the documentation for the API. It's huge, as said, but it's really important to fully understand what's going on. And share your ideas, API clients, patches, proposals, everything else. Thanks a lot.